Now let's look at the effect temperature has on solubility. So let's consider solids first. So most solids will increase their solubility as the temperature goes up. So we'll have, it could be a curve or it could be a straight line. So most solids will increase their solubility in solution as the temperature increases. And you can test this at home if you take cold water and you try to dissolve sugar in it. Some sugar will dissolve, but if you take very hot water, you can dissolve a lot more sugar in hot water than in cold water. Gases behave the opposite way. So when you raise the temperature of the solution, the solubility of gases decreases. And you know that from intuition, because when you take like a soda, like a Coca-Cola or Dr. Pepper or something, and you have it cold and you open it, not much carbon dioxide escapes. But if it's hot, then when you open it, a lot more carbon dioxide escapes, because a soda is carbonated, just carbon dioxide dissolved in water. And so when it's hot, less carbon dioxide will dissolve in the water, so more escapes when you open the soda. Now, gases also respond to the pressure. And we have what's called Henry's law, which says that the solubility of a gas in moles per liter is equal to Henry's law constant times the partial pressure of the gas over the solution. So as the pressure of that particular gas increases, its solubility will increase. So if you have a soda and you have a large partial pressure of carbon dioxide over top of the liquid, more carbon dioxide will dissolve in solution than if you have a very small partial pressure of carbon dioxide over the liquid. Then the solubility will be decreased. Okay, let's calculate the solubility of oxygen in water at sea level, 1 atmosphere pressure for the air pressure, and see how much oxygen is normally dissolved, say, in the ocean or in a lake at sea level. So we have Henry's law constant for the oxygen gas, and since the solubility of the gas is highly dependent upon the temperature, we have a Henry's law constant value for each temperature. So I've picked 25 degrees centigrade from a table. So the solubility from Henry's law for oxygen is equal to Henry's law constant for oxygen times the partial pressure of oxygen in the air. So this is not the total pressure, this is the partial pressure. So air is 21% oxygen. And about 79% nitrogen. A little bit of trace amounts of argon and carbon dioxide. So the partial pressure of oxygen at sea level is just going to be equal to 21% of 1 atmosphere, and that's 0.21 atmospheres. So the solubility of oxygen is going to be equal to Henry's law constant. And this is molar per atmosphere times the partial pressure of oxygen, and at sea level that's 0.21 atmospheres. So the solubility in water for oxygen is equal to 2.7 times 10 to the minus 4th molar. Okay, just as a comparison, let's compare a few gases and their Henry's law constants. So we saw oxygen, and if we look at nitrogen, it's less than oxygen, so less nitrogen dissolves in water. Then if we look at carbon dioxide, it's almost, carbon dioxide can dissolve in water than oxygen, so we can have carbonated beverages. And then if we look at ammonia, you can really load up ammonia. The KH is 58 molar per atmosphere. So water really dissolves ammonia gas. So this way farmers can dissolve a ton of ammonia in water, and then they can spray that solution onto their fields as a fertilizer, a nitrogen-based fertilizer. So water will dissolve a lot of ammonia, which is convenient.